Welcome to another video. In this video we are going to do an initial static analysis of an unknown binary. We're going to get the unknown binary from this book, Practical Malware Analysis. A lot of people have recommended this book, and I will also recommend it. This is where you can buy it from, and I downloaded the labs. I followed this link right here and unzipped it using the password specified at the download page. And here is the lab 0104 binary that we are going to work on today in this video. If you're curious, these are the tools that I'll be using for this video to answer these 6 questions. So let's get started. The first thing it says, upload the executable to VirusTotal, and does it match any existing antivirus definitions? So I always like to start and have a running log. So here we are. So it's August 2018, and we are going to do lab 01-04.exe, and the first thing we will do is a hash. The hash of the file, it's a mathematical outcome of some very long algorithm, and we can use that hash to make sure that the file doesn't change. So if you were going to go further with the police or with some sort of a criminal investigation, they will want to make sure, everyone will want to make sure that the file that you're analyzing, the file that gave the result, is in fact the file that they are looking at, etc. So the hash, we'll just do the MD5, which is a little old, a little long in the tooth. It's really fast. You might have noticed that, but it's not ideal anymore. There's been a few collisions. So I'll also take note of the SHA-1, Control-C, Control-V. So let's close that. We can now go to virustotal.com. Open that up. I've already opened VirusTotal. I can just drag and drop. Okay. You'll notice that they are using SHA-256, so the hash that we took and the hash that they have provided are not the same. That's a bummer. It would be great if we aligned our hash with the SHA-256, but we will not do that. You can see clearly that there's a whole bunch of matched signatures from all of these products on this file. We can take a look, and oh, there's the SHA-1 and the MD5. So let's take a look. So 93, 69, D80, perfect. I normally look at the beginning and then at the end. So 7587FE, 7587FE, that's fantastic. You can see it's a Windows 32 executable. It's in PE32 format, which is great. There's a whole bunch of other stuff. Do we have anything else? Okay, so clearly it comes from Practical Malware Analysis, or it calls home to Practical Malware Analysis, which makes sense. What else do we have? So it's going to try to do a network request there. It does a DNS lookup there. And those are the files that it looks up, and it writes that one. It deletes itself. It deletes that other file and does some registry stuff. Interesting stuff. There's an awful lot of really good material here, so you could look deeper into that. I'm going to more or less show you all of the things individually with different tools, all of the same kinds of information. So again, VirusTotal really does a good job very quickly of getting you all of that information, or you can, search for yourself. Someone has already looked at this back a couple weeks ago, or last month, I suppose it would be. So we can just, that's about it. There's really not a whole lot more to say. So VirusTotal matched signatures has been analyzed before And what was the behavior? Behavior. It has some web in it. It has DNS. It had some file copies. We can easily check with relatively decent confidence if we look for strings. So I'm going to go to Bintext. I'm going to pull the file in, just drag and drop. And what I observe immediately is there's an awful lot of text. We can kind of walk through it. A couple of things. So here are the things that sort of catch my attention. All right, so first thing, there's one, this program cannot be run in DOS mode. So that's already there. That's a fairly typical message that's normally at the top of almost every executable. We have some close handle, open process, get current process, create remote thread, get process address, and load library. So those are sort of process management bits. We have some write file and create file. So now we're interacting with the file system. Size of resource, load resource, find resource. Again, those are resources. So resources are like containers inside of the executable file. So that already gives us something of an idea that we're going to have to look for resources. Modules, we saw that. Get Windows directory, that's an important one. Move file, get temporary path. Kernel DLL is where a lot of those methods will be stored. Adjust token privilege, look up privilege value. We have a lot of interesting things, a lot of things going on. STRI-CMP, so string compare. We have some, I'm going to call them sort of the STDIO, or the standard input and output methods or functions. Now we have this /system/w update manager.exe. That's a peculiar thing. There it is again. And we have WinUp, WinUp.exe with another, this program can't run in DOS mode. Get Windows directory. Starting to see some patterns. What else do we want to see? Here's a URL. practicalmalwareanalysis.com/updater.exe, I think it is. Again, we've talked about those. System Win Update Manager again. Get Windows directory again. URL download to file. So that's consistent. Exit. Bunch of simple things. And there it is again. Okay, so indications of file being packed. No. Plain and simple. And this is concluded from Bintext. But let's don't just trust me there. So we'll go over here. We'll use PEID, and I think that we can also drag this right into there. And so we have the linker information, and we have a packer, or sorry, we have the compiler information instead of a packer. Typically, you'll see a packer signature there if it's packed. You also see Windows Subsystem, Windows 32 GUI. We go through here, all of this stuff, and here's the import table, right? These are all of those same things we were just looking at. So you can see everything in this, and I think we can even, there's the 4 sections. Let's just move this. PEID likes to be on top. So let's see. We go PEID. First, no packer signature. Let's see. We have the sections. We have the .text, the .r data, the .data, and the .r source, resources, resource. So these are sort of the standard 4. When files are packed, typically what happens is a bunch of these, if not all of these sections, are combined into a new section that is like a zip file. And then there's an additional replacement section that is effectively the unzip part of the packed program. So when you double click on the file, the unzip part of the program starts. It reads that section of all of the compressed data and then writes the uncompressed version back into sort of memory of the computer, and it continues. So when I see this, I say, no, not packed. So I'm going to exit that. I'm going to say, no, it's definitely not packed. When was this program compiled? Okay, so in order to learn about these kinds of details when it's compiled, we need to look at the details in the PE file. So the PE file is a whole bunch of, I'm going to call them tables of information that contain all sorts of stuff, all sorts of pointers and information about the file. We will use, let's go PE view is probably one we can use. PE view, we can open the file lab04. And you can see there's all the sections. These are, so again, this is all of the stuff. If I can kind of pull this open more. If you can read here, this program cannot be run in DOS mode. So we've seen that message in kind of a nicer format before, so we understand where that came from. If we go to the image NT sections and then the file header, we have the date and timestamp. So this lab 01-04.exe was compiled on 2019-08-30 2226 and some change. This is in the future. Just like you can imagine, all of these data are stored inside of the file, so a clever hacker can go into the file and they can change those timestamps to really make it anything they want. Do any imports hint at the program's functionality? So let's talk about that. Imports. And then hint at functionality. Let's go back. One of my favorite programs is PEID. So we'll just use that. We'll slide that, pop that in there. We can go to the GUI. So that was me clicking on the subsystem on that arrow. We can go to the import table. We can look at the import table sort of in binary form. Actually, before I do that, I just remembered, let's put that up here so we have lots of screen real estate. Click that again. Move this guy here and then go to the import table. All right, so those are the three DLLs, dynamic link libraries. Those are the files on disk that store a bunch of methods that Windows uses, methods that any programmer can use if they so choose. And so these are those ones. So let's do this. So we have kernel 32. We have ADV API, so Advanced API 32, and MS VC as in Microsoft Visual Studio Runtime. Let's start with runtime. I mentioned that we had the standard IO sorts of libraries. So there's SNPrintf, exit, these are all of the sort of, there's that STRI comp. So this is all the, and I'm just going to say standard IO.h methods that one would use, right? This is so typically included in every program, right? And those are just all of the utilities of printing to the screen, all that sort of stuff. So that's a little bit less interesting, always there. Let's look at Advanced API. So click here and we have open process token, lookup privilege value A, and adjust token privileges. Now I don't know what any of those actually do, but if I think about Windows and I think about how privileges work when I want to install something, I have to, click yes, and sometimes I have to type my password in. So this seems like that sort of thing. But what I can also do, I can go ahead and I can go to MSD and the Microsoft Developer Network, and I can just for a moment pretend that I'm a developer, look up privilege value A, and then MSDN. And I can go right to the developer resource. And so the lookup privilege value function retrieves the locally unique identifier used on a system to locally represent a specific privilege name. So, whoa, that's a lot. How about adjust? Let's go. Let me just slide this around. Adjust token privilege. Right there. Okay, so this library call, this method function, enables or disables privileges in the specified access token. Enabling or disabling privileges in access require that privilege thing. Ugh. So, not great. Yeah, so what we can see right from that, so let's just put this away for a second. So this is, we query privileges, and we, it queries privileges and tries to set them. That's not good. And these are process privileges. Kernel 32, get process address, load library, write file, create file. So let's see, we're going to find process address. We're going to try to load libraries. This isn't necessarily a bad thing. We're going to exec, so that means run new processes. Write files, create files, resource, manipulate resources. Remember I told you resources were like containers that exist inside of the executable. They hold stuff. It can be almost anything, and you can write them out to disk. That's an important thing. Move files, so we got files, get temp path, get current process, open process. So I'm just going to close that. I think that we've kind of, well, we've looked at it. Let's take a look. We have this resource. Let's click on here, and we have a custom. We have a resource that's called 101, which is consistent with, us needing to use, if we go back here, manipulate resources. Let's do file format word wrap. There we go. Right, so we're going to manipulate resources. So there's something in a container stored inside of this file. So we should probably take a look at that right now. This is not the best view, so let's close that. Let's close that. Let's exit here, and let's go to the resource hacker. That's going to be nearly the perfect tool for that. So RH for resource hacker. I think if we pull that in there, there's that 101:1033, and lo and behold, let's take a look. So first of all, MZ is the standard, I'm going to say signature, the standard first bytes, identifier bytes for a binary executable. We've also seen this before. This program cannot be run in DOS mode. So that feels like the resource stored inside of the executable is another executable. But we don't know that for sure, so let's see if we can save. Let's go save resources to a bin as in binary file. And we can do that. And so that's bin 101. That sounds good. Save. Is it there? Yes, let's just put it right here. Put that there, back. We found a resource inside the lab 104 file. Used resource hacker to save as a resource. Okay, what we should do is we should take a hash of this new file. Start with that. Drag this guy across here. We'll copy the MD5. And the SHA-1. Oh, and we could also do a SHA-256, but some of them start to take a little bit too much time. So we'll just stick with the SHA-1 for today. Okay, so we have that now. Now, really, what we should start doing is we should kind of go right from the beginning with this bin file. So we called it a bin101.bin. So let's take a look at the text, the strings. Drag that across, open it up. First of all, we see cannot be run in DOS mode. Again, that sort of suggests that it's a Windows program or it's a Microsoft program that will run. Get Windows directory, so that says a Windows program. We have URL download to file. That's a thing. URL mon.dll. That's probably the DLL where this method lives. A lot of stuff that we don't care. winup.exe. Then system32 winupd manager.exe, and then we have this URL updater.exe, and again some more duplication, something like that, and there we have it. So curious. So what can we say? So let's see. We see indications that it is a binary executable. It finds Windows directory and downloads something from practicalmalwareanalysis.com. Something. These are just things. We don't know for sure. We had some file names in there. What else? We can do the PID thing on that. Pull the bin in, and we can see again Visual C6 GUI. Click on that, go to the import table. There's that URL mon, that download to file. We have the standard, again, the simple S&M printf, and kernel. We're going to get the Windows directory, get a temp path, and execute. Exit. So if we were unclear, let's see, I wonder if we can do, how about this, urlmon.dll, download file. That's the one we saw. And so downloads bits from the internet and saves them to a file. What could be more, I don't know, distressing? All right. So what host or network-based indicators could be used to identify this malware? So this is us asking for if we were going to create some sort of a host-based IDS or a network-based IDS. So let's see, host-based indicators. So what would we have? I think it was called winup.exe. winupt, wupt mgr.exe. Okay, I think that's it for this one. How about that guy? Just those three, really? Yeah, I think that's about right. Again, there's a bunch of other things that we could pick on, but they're going to be sort of not unique to this malware, and we don't want to all of a sudden capture all sorts of benign programs. Okay, so network-based. So this is really going to be that practicalmalwareanalysis.com. Files named, and then accesses to. This file has one resource in the resources section. Use a resource hacker. We did to examine that resource. We did, and then extract it. We did. What can you learn? Well, what did we learn? This. lab01-04.exe is a malware that downloads a resource from the internet and tries to save it to the local file system, presumably to be run in the background from this moment on. That's conjecture. I don't know that for sure. This sort of overview static analysis is we're done that now. Where we could go from here, we could go to an initial dynamic analysis. Dynamic analysis has me executing the file. And executing the file might be risky, especially if already I sort of, see this level of distressing data that I'm pulling out. We could also go deeper in the static analysis, and we can open it up in a disassembler like IDA Pro. And we will do that later, not now. This is just a simple sort of, let's get started, let's take a look, let's examine, what do we see? It's a black box, what can we pull from it? So we've done a really good job there. I would say from here, clearly it's more likely bad than good. We have a bunch of things we should worry about. If we do run it, we should probably, look for files like this. We should connect to or try to capture traffic from that place. Yeah, lots of stuff, but really this is as far as we can go in a sort of a simple overview initial static analysis. So I'm going to go ahead and close this. I'm going to close this because we're done with that. And last thing we got to do, let's just go back to hashcalc. Go back. So we have 936 and then 87 FE, 936, 7 FE, perfect. And then 625 AC, 625 AC, and 79 AB. So we know that that guy hasn't changed, and the resource, so 6A95, 6A95, and then FCE8, and then EFB10, and then 33D4. Perfect. So then file hashes still match. So that's the end of this video. So I think we can consider ourselves having answered these questions, the 6 questions, effectively. We've got a bunch of information stored now. We have a bunch of data that we can use to support further examination, to already deliver preliminary results to the head of investigation, if this were a real investigation. So that's it. Thanks so much for watching, and we'll see you in the next video.